basically radicals. Those radicals then can propagate and then eventually combine with each other, basically to form either alcohols, aldehydes, or carboxylic acids. Okay, and that can be a big issue in a turbine system. Okay, the reason that is if you take a look at group 1, group 2, group 3, group 4 base oils, they all have different properties. So if you think about solvency, group 1s aren't as saturated, so they're going to be more likely to dissolve polar materials versus, say, a group 3, which is going to be more saturated, less polar, it's going to have a harder time to dissolve polar species. Okay? If you look at the oxidative stability, as you go from group 1 to group 2 to group 3, you get better performance. So really what you're looking at is a little bit of a trade-off. As you go to group 2 and group 3, you get very good oxidative stability. The downside is when you do start to form oxidation byproducts, they aren't as soluble in that base oil. Okay, so this goes back to the slide that I had with the molecules on it. If you look at the relative rate of abstraction of that hydrogen atom, the hydrotreating process basically makes group 2 and 3 base oils tougher to oxidize. Okay, so if you get varnish in a turbine system, what happens? What's the real problem? What does the end user experience? Okay, one of the things that can happen is you get a delayed response of valves. Okay, so that basically can prevent the turbine from starting. Okay, so with peaking turbines, okay, which are just turned on to provide they're in peak energy demands. If those turbines don't start, the power generator is in a tricky situation because they were promising power to supply to the electrical grid, and now they can't provide that. So that's one issue. Another issue is as deposits form, they can form on the filters. Okay, so now your filters don't have the capacity to hold as much contamination as they used to. There's a seal in the system called in the hydrogen cooling system in the generator set. That can be affected and can reduce performance. You also lose a lot of your heat transfer. Okay, so as you form these deposits on the surfaces, you don't have the ability to dissipate heat as well. So the system can get hotter, that can trigger more oxidation, more varnish, and the situation can really start to accelerate. Okay, so higher operating temperatures on the components, higher operating temperature for the lube oil, and you can also have restriction of flow because of the varnish. Okay, so you have some very tight tolerances in some of these turbine systems on the order of 1, 2, 3 microns. Okay, so one of the things that Lubrizol does is we go out and we take a look at the market and the end users, and we try to understand what the end users are experiencing. So as we develop products, we can try to formulate products that either A, solve problems, or B, they may not realize they have a problem, but maybe we can make their system more efficient or more reliable. A lot of times the end users won't really realize the impact that an oil can have. Okay, so we went out and we asked in a survey, we asked turbine end users, said, what are primary maintenance problems related to your gas turbine lubricant? And you can see from the survey that you got different types of responses, but the one that jumped out was, hey, we have valves that stick. Okay, and that's due to varnish.